Hello, hello. Woo, woo. Wow. That was super duper fast. Hello, hello. Welcome. All right. Well, I mean, we got this is definitely fast. So, with it being the way it is, I wanted to change one thing about the rotor. To make these spokes on a 30-degree angle. So if we can get lift or, a good fan out of this, just change the angle of these spokes a little bit in the 3D CAD. Right now it's got a downdraft, like a steady downdraft. Yeah. All right. We turn the power back on. Make sure that's good. Hello, hello. There we go. There we go. Now I got 31 volts going in, 300 milliamps. Got two piezo's hooked up to it in parallel. Awesome. Oh, I haven't got a max speed yet. The shaft, it's unbalanced somewhere. I don't know where though. Maybe in the bearings. So I'd say max speed is right around 1600 RPMs right now. Without it like getting too out of control. But we can test it. We can get that like right now. And turn it back on. No. No, this is more or less a tabletop toy for experimenting with, speed and motor. I can generate electricity, but it's nothing snazzy. 1,000 RPMs. Just a second here. Yep, 1,000. 4,100. You gotta divide by 4 though. So, 1,100 RPMs right now. But you can see that shaft is starting to wobble. $46. Then divide by 4. You can hear the piezo's clicking, man. That's what that sound is. No, no free energy. Not here, anyway. All right, now that shaft is shaking quite a bit. I'm going to have to try and reposition it. All right, let's see if that worked. Now I'm going to run, there's 2 drives here. I'm going to run the other drive now. This one's got 75 volts going through it. Wow. Wish I could push the shaft down farther so there wasn't this big thing on the top just flopping around. Think, McFly, think! It's a motor. I'm not trying to reinvent anything. You know, if I was trying to do that, I would show you more of my face, less of the thing that I was trying to invent. This is there's 2 drives though. It's really simple. I wouldn't necessarily call it reinventing anything. But I did have this vision of a tricycle, like a motorized tricycle, one of the big tricycles. And those wheels could flip to a horizontal position, and they have helis in them, plasmastic helis. So like you'd be floating on plasma at the push of a button. Be sweet. I have one rodent coil. It's a 36.2 dimensional rodent coil. And that's the only one I've done so far. I haven't made any of the 3-dimensional ones. $31 volts. That's a rotor moving about 1200 RPMs. It's a kind of a DC brushless motor. With, you know, I made it with bits and pieces found over time. I didn't even know what it was called when I first started making them. Like, what do you call this? They're like, it's a pulse motor that you're building right there. And I was like, really? Well, and you can see that when I started out like 2.5 years ago, I used a reed switch, and then all my stuff moved really, really slowly. So like I wasn't doing it right. I've learned a lot over the past 2 years. But I still haven't got off pulse motors yet. I'm still having a lot of fun with this. But eventually I'm going to want to get into more Tesla coils than rodent coils. and try and get some, you know, power, just for power purposes. It's a great tool to transfer power through resonance. Great tool. So I want to make that tricycle that can fly, right? Basically, using plasma as the power source to run 3 helicopters in the wheels. What's up, Mike? How's it going? Mike does. He's a big deal about how I learned all my stuff. That's the truth. All right. No kidding, senor. All right. So there's two 90-degree drives here. Um, so there's 8 coils basically. This is one drive. I've got 2 piezo's hooked up to this drive and 2 hooked up to the other drive. This is 31 volts going through 16, 20, and 24 gauge wire. Now I'm going to do the other drive. I can't wait, man. I'm just going to do a few more things and then I'm going to dismantle this table and rebuild it in a much flatter, smoother way. Right now, I'll show you the dip in this thing. It's freaking amazing that anything works. Oh, you hear that? Woo! That took like 5 seconds. Yeah, I don't want to test that. That's already going faster than it was with the other circuit. Yeah, so I can run them one at a time. I can run them equal at the same time. They're not going to be equal. So, but that one, as you can see, is way overpowered on one side, I believe. Or that imbalance could be in the bearing. Like the bearing could be too big for the pole. I can kind of feel it jiggling on there. So the problem is definitely on the rotor, and maybe in the balance in the coils, but yeah, it's definitely loose. Does anybody know how to like fill in a freaking microcosm of freaking space? Oh my God, that is like such a. But that's what happens when you eyeball stuff. Quarter inch doesn't always mean a quarter inch. But it's nice and smooth on the pole, so whatever it is, it's on both bearings. All right. So I was thinking about another setup here where we use this coil as the trigger drive and then put this coil and this coil on that 3 magnet rotor over there, because that one is very well balanced, and that one I believe can get up above 2,000 easy. Right now, I guess we're just trying to get RPMs out of these things. But here, this one, I took all the 32 gauge out of the system, and that's why it's responding so quickly. All right, I'm just going to let it speed up, and then I'm going to turn it off and turn on the other one. Because the other one responds better when it's going fast already. And I'm just doing this to show you. See the light? There's a big light. Ooh, man. All right, yeah, we're definitely going to have to do something. And it's not really a flywheel. I mean, it is heavy, but it's really tiny. So there's no like force involved with it too much. It'll stop a lot faster than like a wider diameter disc. But I mean, with how much of fast it was going, it's going to go for a while. All right, let me just show you the cool part for those of you who don't know about this rotor. See, the bottom is just part of the rotor. But, you know, you flip it upside down, those magnets are in there good. They're in there good, real good. They're magnetically held in there from the iron infused PLA on the bottom. And then and there's carbon fiber on the top. And then the magnets are south facing out. So all that north is in the center. And then the mag down there is north facing up. So boom, mag left. Pretty. Yes. Oh yeah, man. I mean, one thing I can guarantee you is that I'm not going to leave this thing unattended ever when I'm using it. It's not like I'm going to turn it on and go for a stroll, you know. I can't do that. But here, so like what I was saying about the other system, and then put 75 volts into it. So this coil and these two gray coils of 20 gauge. So the whole system is 20 gauge. And then the trigger is 32 gauge. That would be awesome. I think that would be so cool. And I mean, with there's going to be less wire in the system altogether. So, and then you could do the same thing you did here. Like when it's like this, when the magnets are aligned like that, you got this one, and this one in the same circuit. And then when you turn it to the 45, the ones that it's lined up with now are in the same circuit. Can't really see it. This one, that one, that one, and that one. And it's just like having one coil, but it's way better. Okay. So there's a lot more torque because the rotor is being hit from all sides instead of just, you know, the trigger coil, the bifilar right here. If it was just this one, it might run smoother, might run faster, but it's not gonna have the same amount of torque. And just judging by how fast it's already going, that might not be the smartest thing, you know. They're all air core except for the two big gray coils. They have soft iron powder in the core. So in a little bit, I might throw this up on a tripod and switch that around. Yeah, absolutely. So what I was thinking about doing was making 4 arms, that link together in the center on the pole. But then it would have to be, okay. I'm not moving anything under there. There's wires all over it. But there's nothing really under here. This is pancake coil, but I'm not gonna take it out of there. There's too much hanging down on here. So I'm not moving anything under there, but there's a broken switch, uh, a box for a PWM, pancake coil, which both ends are underneath. They're not hooked up to anything. Yeah. So not much underneath here. Yeah, I got a thicker rods over here on this setup. So yeah, no, you're not wrong. All right. Now, if I drop that wheel all the way down to the table, that would stabilize it a little bit, but I'd lose the maglev. Yeah, definitely gonna need to stabilize it. Let me hold on. Let me get this out of here. Oh, look at the screws are popping up. All right, I'm gonna have to screw those back in. See, now this is an Utron. And it has big rectangle magnets that fit in here. And then this is supposed to be elevated a little bit and be able to spin on the inside. See how that's free to spin? And then the other thing is, it's just like nanometers off of working like correctly. So I got to redo I'm going to start by redoing the rotor, making it a little smaller. Printing my own bobbins, making everything just a little bit smaller. And then it'll work. It's like within nanometers of working. And the only reason it is the size that it is because I was going to use these store-bought bobbins to make the coils. But like I said, nanometers, not even. Just enough so that it's too big. So I got to print my own bobbins. I got to make it a little bit smaller. But I can do that. All right, I'm going to be away from the keyboard here on the camera for a little bit while I screw those down and maybe set up the 120 degrees. Wow, there's a lot of magnetic pull on the coupler down here. It is definitely magnetized. But the rod is not magnetized. But the coupler that's holding it into the table is definitely magnetized. That's a lot sturdier already. Oh my goodness. Let's get one roll with this all screwed down. And then I'll think about changing it up. Let me put this away. Let's see. $1,100. And that's 31 volts, drive number one. We'll turn this off. And now we're going to do secondary drive or booster drive. Booster engines. Here we go. A lot sturdier with the pole. That's awesome. All right, let's get another reading real quick. All right, let me show you what we got. All right, 7 divided by 4, 7,120 divided by 4, and then add 200 divided by 4. So let's see here. 1,750, something like that. And that was really sturdy for 1,750, man. That was great. So I'm glad I opened that up and looked in there. All right, so we're gonna let this go for just a second, and then we're gonna turn this one on at the same time. We'll see how long it takes. Ooh-wee. All right, I knew that was coming. Woo! All right. I didn't get a good reading on that. That sucks. The reading I did get was 6,503. But I'm sure it was going faster than that. All right. Well, yeah, I don't know. I could definitely, I think it's just awesome how fast this thing gets going. But it kind of sucks that the shaft is so small. But I think the next thing I'm going to do definitely is hook up the 120s with those 3 coils. This one, and this one. All that 20 gauge is going to be rocking with the torque. But I mean, as you can see, this is a pretty intricate setup. When you mention it, it's simple. It's really simple. But as you can see, it's all over the table. Yeah, there we go. Just that rapidly spinning north is probably unscrewing all my screws. And then the jostling, the vibration, same thing. The pegboard is going in the trash as soon as I take the table down. You know, I'll either set it up the same way, or I'll have, you know, a double stacked layer of plywood underneath it. Because this is just pegboard right here, and it's got a 2x4 going down the middle. I don't even know what I was thinking, but I don't know, it's lasted for so long. All right, now well, I don't know if I'm going to do that switch to the 120s online. No, I don't know if I'm going to do that. Maybe. Yeah, I guess I could. Just that this coil, some of these coils are a pain in the butt. No, I'll do that on a different one. I really feel like it's another project in and of itself, even though it's just another pulse motor. So that's an external trigger coil though, right there is working this thing. 31 volts. Wow, that sounds insane. Let's look. Almost 1,000. Those seals pesos make it sound like it's going faster, but it only sounds that way. Alright. Well, it's hovering around 4,000 divided by 4, so about 1,000 RPMs like that. There we go. Eleven hundred RPM. No. Yeah. I think this thing needs batteries. Alright, so I need 3 neodymium cubes. Even if I don't like put it on there today, I should set it up. The neodymium cubes usually come in pairs. They usually cost anywhere between, 15 and 22 bucks. Yeah, that, indeed, when these things come together, like the magnets, the N52s, N54s. Yes, there is an N54, or they call it an N54. Yeah, so we're gonna try that. And this here would have worked on this too, but it's like it's on the shaft and it doesn't fit exactly right. But I have this 8-magnet rotor that's on the shaft. It moves all right. Of course, it's a lot slower than one of these though. We're doing south facing out so that it matches this rotor that's currently in there the best it can. You can get a pair of these neodymium cubes for like 22 bucks, 20 bucks. Some are cheaper now. But what I'm saying is that if you need 3 and you're spending 46 bucks or something. All right, sweet. Let's make sure south, south, south. Nice. Now that is just one part of getting this set up. All right, so we'll go clockwise. Hello, hello. Well, I don't have my signal generator out yet. I was gonna hook it up to this and like later on today. That's a good idea, actually. So this is a 4-magnet rotor. What I'm proposing is that we make the diameter bigger and put 3 magnets in the rotor instead of 4. Since we're not really we don't have any pickup coils on here, so we don't need the extra magnets. Hmm. And this here is another rotor. Looks like a shaft that we can use. It's got ceramic magnets, ceramic ferrite magnets in here, grade 8. There's 6 magnets in a 120 spread rectangles. So this is pretty cool too, and it whips, man. It goes really fast. But all of them are like small. Like I only have one nice sized one. That's a 14 incher, and it'll spin on its own like flywheel power for a while. But if you're going to do flywheel, you should definitely have some sort of pickup to siphon the energy from the wheel. But yeah, this one, not so much. Now that 3 mag rotor that I just built, uh, that one will definitely spin longer than this one will. A lot longer. Just on my hand spinning it. This one is it's 5.5 inches. It's not even 6 inches. And the toroid that's linking all the magnets together is only a 4 inch. And like lines up almost exactly with the one underneath it. That might be a problem too. It's so close. I'm not gonna mess with it. All right. So who wants to see that 120-degree circuit? Hello, hello. This is 290-degree circuits. So I'm thinking at 31 volts, I'm probably going to get right around 1200 RPMs with this rotor. Now, that coil is a little far over. So this is the small circuit. This is the 31 volt circuit. Now I can run them one at a time or at the same time. I'm going to run them one at a time right now. All right, so I'm going to turn that off. And I'm going to move mosey on over here to the power of the primary driver. Maybe we'll make this the secondary with the booster engines. Well, it's not a microwave transformer, but it is a transformer. No, sir. I don't haven't tried a microwave transformer yet. I like rolling my own. But there, if you can't, or you can't afford it, or for whatever reason it is that you can't roll your own, finding a coil and a microwave transformer is always a good bet. This is running on 30 watts. I'll show you real quick. I gotta get it going again. So just take a second. So it's kind of a primer drive right here, because it has to go a lot slower to get going on the wheel. The wheel gets going because that trigger drive is a lot more sensitive on the other one. And just get it spinning. This thing doesn't like to have all that amperage pumped through it without it being pulsed. See what I mean? That's our wattage right there. Being pumped into that transformer right there. Yeah, that's awesome. Problem with that one is that it gets hot. This one can run all day though, this one over here. And you could tell the difference in the sounds of the piezos or the pezos. Piezo. With the less voltage, it's like a more deep frequency. But this one is working with 30 volts and 300 milliamps. What is that? 9 watts? Or is that wrong? That's 9 watts, right? In our Bedini style circuit, there's our light bulb. It's a halogen bulb at 120 volts. And there's our circuit. Simple, easy peasy. 27 on the one, but we're getting 75 volts out of that, or like 60 volts. So there's a conversion rate in the little box that I showed you that changes it all to voltage. But yeah, it's 27 watts on this one and 9 watts on this one. Because here it's 300 milliamps, over there it's 3.5 amps. All right, well, this has been fun. I really like showing you guys what's going on here. And I'll probably be hooking other LED up to this drive that I was just showing you. Currently, there's no load on it. But the other The other drive, the one that shakes everything, has that light bulb on it already. That's a 100-watt light bulb. It's supposed to be 1,000-watt, metal halide, but they did some magic with it, so it only cost 100. Sweet. So this is a primary drive. And now we're going to run them both at the same time. Woo! Thank you, Jason. Thank you. Yeah, that's crazy. That's high voltage right there. Definitely gonna the near future, because I'm probably gonna do that 120-degree circuit, and then I'm gonna take this thing apart and build a better one. I need that. I need a better space to work. See, I've removed coils and glued them down so many freaking times where they need to be that I got holes. I got big holes in it. But yeah, man, it's just my desire to share. I really have a strong desire to share. So I don't know. Some people dig it, and I appreciate that. And some people think it's just a big old mess, which it is. And I appreciate that too. Your opinion about it, matters. Especially if you're going to leave a comment saying this is a big old mess. I mean, seriously. And I'm sure that people that are saying that can do way better, right? I think it's nice and tight. Me personally, I mean, there's a lot of wire here, but it's all right as long as none of it gets crossed. Awesome, man. Thanks, dude. Yeah, it's awesome. Thank you very much, Gerald. I appreciate that. I was going to show up on Mike's presentation last night, but I fell asleep at like 9 o'clock. Mm. That is smooth, man. That's 31 volts, 300 milliamps, and it got going this fast in less than a minute. Wow. All right, now I'm going to turn on the booster engines just for a second. Let's see what happens. Ears peeled. Oh, there we go. Woo-wee. Yeah, that's flying. I love that. So it gives you a quick burst of adrenaline. But I knew that was coming. I'm glad I knew that was coming. So let's see if I'm right about this. Yeah, those screws. See, this pegboard's done. The screws are still like popping out of there. So we lose a lot of stability on the upper just for it being a little loose. But I think that 3 magnet rotor over there is going to be a way smoother ride than this one. I don't know why. Man, I wish I got a reading on that one, because before it let loose, you know. But my tach meter was over here. Because now I got to screw them down in there again before I can run them both again. Might be able to do primary without it, but you know, it's not really worth it. Yeah, man, I don't know, dude. The thing about me, yes, sir. Yes, sir, Reason. How are you doing today? Thank you, thank you. Welcome, Yanni. Now, yeah, and when I do it, I'm gonna make it a lot more secure, firm than it is. This is not even it's about a 1/4 inch actually of thickness, and it's cork board, or you know. And then look at this bow that's in there. You can see it like going like this, but that shaft is going straight through that 2x4, but it's still not enough to keep it sturdy. And it is probably making this pull a little sideways, just because, even though it's down the center as it could be. See, the thing about these cork pegboards, there's no center hole. There's no center to this thing hole-wise. It's in between 4 holes that's in the middle. So it's it is actually a DC brushless motor that runs, let me think here. This is a 75, let me put it this way. This is a 75 volt converter. So it'll take from the power supply what it needs to make 75 volts. And I have a light bulb that's we're going to say that it takes 25 volts of raw electric to light it up. Okay, so you get 75 minus 25, you'll get 50 reading on the coils. So I don't know. I say it runs on 50 volts. So let me turn it on. Well, we'll see what happens here. I'm just going to turn on the primary drive so you can kind of see what this does. I'm going to stay over here by the switch. So it's just a motor, and I don't have a load on this one. It's 2 motors actually on a 90 degrees on the rotor. So there's 2 circuits here. This is primary drive, I call it. Uh, 1000 RPM. 1050 or 1100. And that crackling noise is the piezos. I have them hooked up in parallel. I haven't found out how to hook them up any other way. I was told to hook them up in series. I don't get that because my thing doesn't work when they're hooked up in series the way I hooked them up. I don't know where to hook them up in series at. So it's like the parallel connection is going to work for me for now. Yeah, these things are popping like crazy. So we're lighting a light bulb. That could charge a battery or do whatever, you know. And I got the piezos on that one too. I think it's cool. Like one is strong by itself. They're both strong by themselves, but they're twice as strong together because all these coils are different. And when they're all on the same time, um, in every off position, there's a coil. You know, this is because it's a 4 magnet rotor instead of an 8 magnet rotor. So right now, this is the off position, and there's a coil there. So when it moves to the off position, it'll trigger the thing again. So you got two. It's awesome, and they work well together. You know, you do this with some other setup, and sometimes they don't work well together. Yeah, yeah, man, those are nice, and they pop. They're it's just so cool. And I didn't get I guess there's different size piezos. These have got to be small. I got 13 of them for like $4. Oh, I'm getting excited about hooking up the 120. Man, that's gonna whip. That is gonna be freaking fast. So about 1,000. I gotta screw that thing down. Yeah, I don't know. This is all right. If you don't hear from me for a while, because I might do a step by step on how I rebuild this thing. So I wouldn't worry about it. But I was gonna say it's because I'm changing this up. I am making a DC brushless motor. That is it's a pulse motor. I'm thinking about hooking up a BEMF connection to like both series, not individual coil, but both series of coil. Is that a vape? That's awesome. Actually, there is quite a bit of a downdraft in the center there. Yeah, except I didn't like buy. I made this. That's the well, yeah, the homemade vaporizer. Uh, that's the current power input. 31, 32 volts, and 300 milliamps. See, now you can get it running like this with just the primary drive. And you can get it running faster than this if you run just the secondary drive. When you run them both together, it's freaking insane. It gets to the point where you can't run it like in 2 seconds. And it's just because my shaft is weak. Like the board here is breaking down severely. So it's literally like in a 2x4, and that's the only thing keeping it uh, together right now. Yeah, so I just like to redirect people. I'm about to go off. Old Man Builds, check out what he's doing. Faraday Research, you can check out what he's doing. Uh, really cool stuff over there. I'm probably glad I can't see. Yeah, man, I don't know. I've done some pretty outrageous things in the past week, so we'll see how it goes from here on out. Thanks, Yanni. Thank you. All right. Well, it's been one hell of a trip. I really appreciate everybody coming in, stopping by, saying hi, and I'll see you next time. Bye now.